Test scores of male students in some standardized stats exams claim to be greater than those of female students, and we have to verify the claim using alpha equals 0.25. Male sample, female sample, of course, independent, not paired. But here's the question: should we do a right tail test or a left tail test? Keep in mind, we defined delta in a specific way last time. So based on that delta, should we test for, or should we do a left tail test or a right tail test? You can look at your notes. So Jimmy says, break it down, so we've got to do right tail, right? So the way we define delta is yi minus xi, right? If we want to find an effect, do we want delta to be more negative or more positive? Huh?
More negative,
Matthias says more negative. Why is that?
because we want the females first to be small.
Because we want the scores of females to be smaller than males. In other words, xi has to be significantly bigger than yi. So the farther we go to the left, the better it is. So the test we want to do, right? Right.
No, left. If you want it to be negative.
We want that to be as negative as possible, right? That would indicate that the male values are greater than females, right? That's the point of the test. So don't be fooled just because we have greater than. Sure, you may say, well, I could change x and y and do the test in a different way. If you want to, nothing wrong with that. Do you see what I'm saying? Flip this, call females as X's, males as Y. Doesn't matter. So first step, put them all together in order. So damn it, didn't want ties. We don't well. Change that to 91. Change that to 5. Okay, good. Sure, I could have done with ties, but I don't want to start a problem with ties, which would require adjustments. So we put in order. $34, $35, $44, $69, $72, $79, $84, $89, $91, $92, $95. Yeah. Good. In terms of the runs, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Sorted it and done it. Now the key here is we simply want to add the runs corresponding to y. Well, 35 is y. 89 is, 79 is, 92, 41, 95. Good. Sticking to the procedure that we developed, because I made changes, even slight changes, then things would get tricky. So I'm sticking to the procedure we wrote similar to the text. W would be the sum of those frums. 2 plus 3 plus 6 plus 8 plus 10 plus 11. Good. So we found W. We want to do critical value of range, which would mean we need to come up with U and U prime. Yes. So we know W is U plus n times n plus 1 over 2. Yes. What is M in our case?
5.
12.
5.
5. M is 5. N is 6. Yes. According to how we define that procedure. So W would be equal to U plus 6 times 6 plus 1 over 2. U plus 18 would be equal to W, which would imply U is W minus 18. Which is 41 minus 18. 23.
Is it W 40, not 41?
40. 10, 19. So U is 22. What do we get for U prime? U prime is U minus Mn. So we'll have 22 minus M times N. 5 times 6. 30. Negative 8. Again, we can't have negative. But now distribution is symmetric about M times N over 2. If U prime is negative 8, what should it be on the positive side? So M times N over 2, 13, 30, right? On the negative side, if it is negative 8, positive 8, right? So 8. 8. Good. So finally, we found the test statistic U prime. Is 8. I did cute Wilcox just to demonstrate as to what the function is about. You've got to put in the percentile that you need. It always gives you the lower tile percent. M followed by N M is for the first sample, N is for the second, and the first sample is X, the second sample is Y. So we're going to stick with the same thing, M, N. So M in our case is 5, N is 6. So alpha is 0.05. We just want to find that critical value over here, right? Because it's the one on the left. On the left-hand side, or U prime minus, to indicate it's a left critical value. That would be our rejection region. If I reject, then I would conclude that male scores are greater than female scores. We will see. Do we reject? Critical value. So it always gives us the lower endpoint. For a specified alpha, which is lower tail. The area below that value is 0.05, the value of alpha. M is 5, N is 6. I get 6. Good. Critical value is 6. What is our test statistic? Don't use W. W is 40, right? We have to use U because everything, excuse me, U prime, because everything that R is doing is with respect to U prime. So 6. Our test statistic 8. Should we reject the null? No. Did we find evidence toward the claim? If I rejected the null, then delta would be less than 0, which would mean yi is less than xi, which would mean female scores are less than male scores. Agreed? We did not reject. Statistically, they are the same. So the claim is false, or not enough evidence to support claim. Good. U prime, even though we wrote it that way, you know, and then it's right here, 22 here, 30 minus 22, it's a 8 difference. 8. Another way of looking at it. What else? P-value. What is the p-value of a left-tailed test? Is it the area above the test statistic, area below the test statistic? Still waiting. Below the test statistic. Now, which one should we use if we intend to use R and the exact distribution? Should we use W, U, or U prime? U prime. So P Wilcox, U prime, which is 8. M is 5, N is 6. P value is 1, 2, 3, 3. Again, is 0.1233 bigger than alpha? Alpha is 5%. I get 12.33%. Same conclusion. Do not reject null. Not enough evidence to support the claim. Good.